to turn off that camera because I will flip my computer now. Okay, so good evening everyone and welcome to the uh, online problem solving session for the course Coordination Chemistry, which is taken by Professor Devasis Ray, and I am Satyaprakash Yadav, a PMRFE scholar from August 2020 batch. I am working with Professor Satish Patil in Solid State and Structure Chemistry Unit, SSU, ISC Bangalore. So, already this coordination chemistry course is 12-week course. So in the week one, we basically uh, has a chance to introduce and define and classification of ligand. And in week two, basically we will again like what are the other classification 2 and classification 3, and we will discuss detail in the nomenclature. So here is the three lectures. In lecture 4, professor has discussed about the classification of ligand 2. In lecture number 5, he has discussed about classification of ligand 3. So in classification of ligand 2, he has taken the different kind of ligand used in, like, suppose catalysis and other part of the application. In the classification of ligand 3, he has taken the ligands from the bioinorganic or in the application in the life sciences. So what are the different kind of ligand such as scoring ring, chlorine ring, porphyrin ring, and all the related compound like chlorophyll, vitamin B12 and the hemoglobin, and all he has discussed in lecture number 5 for the classification of ligand 3. And then he has discussed the nomenclature 1, and in lecture number 6 he has discussed the nomenclature 2. So I will just briefly go through the nomenclature. So in the nomenclature of the uh, of organic coordination compound, sorry, just have to sorry. Coordination compound. So there is the set of rule which I will discuss, and then I will go to the uh, like uh, problem solving session. So first rule is that suppose this coordination compound, it will be either ionic or it will be neutral, right? So if it is ionic, so we have to write like cation, then we have to give one space and then anion. If it is neutral, we will just write in one sentence. One sentence. This is the first basic rule. So if our coordination compound is ionic, we have to like in that two, one will be the cationic, another is anionic. So we will discuss about the cationic organic compound and having anionic coordination pair compound. And in neutral, just we will write in the one sentence. So this is the first rule. Second rule, so we have to see that whether that complex ion, our complex ion means our coordination sphere, whether it is, so this is this coordination sphere, coordination sphere, whether it is neutral or it is cationic or it is anionic. So when it is neutral, we have certain rule. When it is cationic, we have for neutral and cationic, we have same rule. But for anionic, we have some different rule regarding the nomenclature of the metal ion. So that I will discuss in the further rule. Okay. Then next rule is So first I will discuss about the detail in the ligand part. So suppose if ligand is there and it is like more than one of the ligand is bound to the same metal, so how we will write the name? So we use this term di, tri, tetra, like that we use this that nomenclature. Suppose two ligand, three ligand, four ligand, five ligand, like that if it is binding in the same metal, so we will use the term di, tri, tetra, penta, hexa, hepta, octa, nona, doca, undeca, and dode, like that. But suppose if ligand itself contain this kind of prefix like a di, tri, so what we will do? Suppose example I will take ethylene diamine. So for this kind, if this kind of ligand bind to the metal in more than one, like two or multiple ligand, then we use for two we use the bis. What prefix we will use? Bis, tris, then like that tetrakis, pentakis, hexakis, heptakis, octakis, all the things we will write. So if anyone need, I will send you that 2-page notes. So you can just at the end you can get it. I will just upload in that where I am uploading that my slide in. Okay. So this is regarding ligand. So now come to the how we will write the ligand. So rule number is 4. Rule number 4 is ligand will be write ligand. We will write how? We will write in alphabetical order. Alphabetical order. So how we will write the ligand name in the alphabetical order in the coordination sphere. So in coordination sphere, if we have more than one ligand, so we will write them in the alphabetical order. So these rule, once I will go for the example, you will easily understand. Okay. So okay, okay. And one more important thing that prefix prefix we will not consider, will be not considered. So suppose if we have this diamine, triamine, so D and T will not consider. Only that ligand alphabet will be we will counting here. 5 rule, like if we have neutral ligand, so we will write them as such their name without the space. Suppose we have like DMSO, CH3 2 SO. So how we will write? We will write dimethyl sulfoxide. Sulfoxide. Okay. So we see if we are writing this DMSO name, we will give some space here. Dimethyl, then sulfoxide. But in naming of the complex compound, we will remove the space from this ligand. So I will just write, suppose we have urea, right? You just go pyridine. So these will name it as such pyridine, sulfur dioxide. Suppose we have SO2, so we will write sulfur dioxide. We will not give the space here while writing the name of the complex compound. So all you can see that dinitrogen, dioxygen, triphenyl phosphine, triphenyl phosphite, methylamine, ethylamine, acetonitrile. So all these things, neutral ligand, their name we will write as such. But there are some ligand which has given special name. So those I will just write. Suppose we have NH3, H2O, NO, CS, NNS. So for NH3 we will write amine. For water it is aqua. For NO it is nitrosyl. For CS, we have thiocarbonyl. Thiocarbonyl. In NS, we have thionitrosil. So these are the neutral ligand which has given the special name. Other, their name as such without space. This is rule number 5. So we will go to the rule number 6. Suppose we have the anionic ligand. So anionic ligand, if it is ending with O, we will convert to ato. If it is ending with ide, so we will convert it to I2. That is the rule, right? So suppose we have this, sorry, this is ATU. This will be converted to ATU. Suppose we have acetate. What we will write it as a acetate. We have sulfate. We will write as a sulfato. So basically, where we have 8 in the anionic ligand, we will convert it to ATU, like sulfato, carbonato, thiosulfato, nitrato. So all those example will come in this kind of rule number. So suppose we have like ide. Suppose we have nitride. So we will convert it to nitrito. We have azide. So we will convert it to the azide. So for the neutral ligand, we have just name without space. Some special ligand are there in neutral compound. I have written the name. For the anionic, if it is ending with ATU, we will convert to ATO. If it is ending with ID, we have to convert it to the ID. Okay, so in the anionic ligand also, there are some ligand which has given the name, like we have Cn minus, we will write as a cyno or cyanide. If we have this F, it is called fluorido. Like this bromido, iodido, oxo, raxo, superoxo, these all like ligand ending with O, we will just given the special name like cyano, chlorido, bromido, iodido, oxo, peroxo, hydroxo, hydrido, methoxo, ethoxo, all these things. In organic ligand, we will write as such. Organic ligand like just we have methyl, so we will write as such as a methyl. Ethyl, propyl, phenyl, like all those will be written as. Okay, we'll go to the next rule. Rule number 7 said that if our coordination entity, list means coordination sphere, coordination entity is neutral or cationic. So usual name of metal used, and we will write in bracket the oxidation state. Okay, so this is the rule for the if our coordination entity is neutral or cationic. So we will use the usual name of the metal and oxidation state. Suppose we have iron, we will write iron with whatever oxidation state, whether it is 2 or 3. So we have iron 2, iron 3. So we will write as such like iron 2, we will write it iron 3. If our coordination entities is neutral or cationic. Okay, so if for other metal, okay, so this is the rule number 7. If our coordination entity is anionic, then we have the special rule. So metal with ending with IEM, we have to replace into ATE. Suppose we have titanium. titanium. So we have to convert it to the titanate. Titan. Similarly, chromium, we have to convert it to like chromate. So like neobate, rhodate, all those things we have to do. So others same. One important thing is that for some metal, Latin name is used. Latin name. So Latin name is like for iron. What is the Latin name? It is called ferrous. So we have to write it as a ferrite. Cuprate for copper. For silver, we write it as argentate. For gold we write as a aurate. So these are the rules which we have to find. One last rule is that suppose if ligand is having the it has two density, so SCN minus. So whether it can bind with like S or it can bind with N. So if it is binding with N, we have to write it as thiocyanate N. If it is binding with S, we have to write it as a thiocyanate S. So like that we have to write it. One more rule is there that I will discuss when that problem solving session is there. So now I will write some of the like coordination compound, and you have to write in the chat box what is the name of that complex. So suppose we have cobalt NH33 Cl CN NO2. Can anyone write in the chat box what is the dynamic nature of this coordination compound? One minute, someone has written the message. Is Cn minus nowadays written as cyanide? Uh, um, no, whatever I have came across, so people are using Cn minus as a cyano. I haven't come across where that Cn minus is written as cyanide in the IPAC name of coordination compound. In general, people can say that, but in IPSC name it is cyano. Okay, so can anyone write in the chat box what is this name of this compound? IPSC name. Can anyone just try? I will just give 2 minutes. Or if you have pen and paper, you just write it and unmute yourself and say verbally. That will be also fine. Triamine chlorocyanonitride cobalt 2. Anyone else? close, but there is some mistake. Yeah, one mistake is corrected by that is not cobalt 2, it is cobalt 3. One more small mistake is there. Yeah, correct. So just let me tell you briefly. So now it is correct. Still not correct. Okay, just let me do. So in the dynamic nature, first we have to find out whether it is neutral coordination sphere, cationic or anionic. So as you see that this is the like no, you can write chloro, not an issue. Okay, so small mistake I will come to that. So first this is the neutral coordination sphere. So we will write metal as such their name with coordination sphere in the small bracket. So first come to the ligand, then metal. That is the nomenclature. In ligand, we have to find out the alphabetical. So suppose this is amine, this is chloro, this is cyano, this is nitro. Okay, so we will find out uh, in alphabetical order. Okay, this is already written in the alphabetical order. So this is amine, chloro, cyano, nitro. Okay, so this is 3 is there. So in this we can't see any di tri in this ligand, so we will use the term di tri tetra like that. So this is tri amine, then we have again chloro, then we have cyano. The main problem is here, this is nitro. So there is two things. NO2 can bind through two way, either N, nitro N, or nitro O. So nitro N is basically called nitro. Okay, N this nitrito O is this is called nitrito when it is bind through O. So here if it is written like NO2 is generally it is nitro. So it's written like triamine chloro cyano nitro, then we will write cobalt. What is the oxidation state? As you have calculated already, it is plus. Got it? Now I will give some more. This is A, this is B. So suppose I have given Fe C5S5 2. Can write it, anyone in writing chat box? What is the name for this compound? Just write in chat box. Anyone is trying? Are you people finding difficulty writing in chat box? Okay, cyclopentadiene hydroiron second. Okay. Anyone else? Anyone else wanted to correct? Okay. So yeah, this also, but there is still minor correction required. Okay, at least you are getting. So let me tell you. So first, this is what? This is organic ligand. So organic ligand name we have to write it as such. So what is this? This is cyclopentadienine, right? Now it's already there. Penta is inside, and this is 2. So we can't write as di. We have to write as this. Okay, this cyclopentadienine. Then we have to write is iron 2. Got it? Is it fine? Devin, is it fine? Yeah. Okay. Okay. Now I will just introduce one more slide. I wanted to just exercise uh, one or two more example. Then I will just close the things. Then I will go to the problem solving session where it will be much easier. Okay. So now I'm going to write some cationic coordinations here. So we have Cr S2O 6 NO3 3. This is again very interesting compound where you can get the nomenclature idea. No, but ligand is negative. It should be in as IDO. This is a organic ligand. It will written as such. That is the rule. And for organic ligand, we will just write it as such their name. like ethylene diamine. There is not like ethylene di, like whatever I do was it. Okay. So can you just write these names? Chromium H2O6 NO33. Just write in chat box. Then I will tell you why I have chosen this coordination compound. Okay, yeah, you are right. This is hexa aqua chromium third nitrate. So this is absolutely correct. So I will just write, and why I have chosen this, I will just write hexa aqua chromium third nitrate. Yeah. So 21 CHE, that ma'am. So this is ionic compound. So we have to write it first cation, and then we have to write anion. So cation written fine, then there should be a space. So you have written correct hexa aqua chromium third nitrate, but there is space between two cationic and anionic space, so that we can differentiate it is uh, ionic compound. Okay, and one more thing I have written, no one has said this trinitrate. Okay, because this tri is for to balance the whatever charges is there, that is +3 on the group. So this tri we will not write, whatever tri die to balance the like oxidation whatever charges on the coordination sphere, we will never write those things on this. Okay, now I will give another example. CO En2 Br2 Cl. And just write in chat box. I will give some more. I will write. You people try one by one. In between, I will just. Okay. One more. I will. Okay. Just write one by one. For second, if you have written already second, go for third and fourth. Then I will discuss. Okay. Anyone else? Second, there is a minor mistake. Devendra Malik nomenclature. No, there is no dichloro. Yeah, but somewhere else there is a minor mistake. Can anyone point out? That's fine. You can write ethane 1,2-diamine also and ethylene diamine, not an issue. But there is, yeah, correct. So here two bromine and one Cl minus. So oxidation state of metal is 3. So as is written, bis ethylene diamine. What is that? Cobalt third chloride. Okay. Now uh, compound 3. What should be the name for the compound number 3? Oh, sorry, I missed here. Sorry, diagram. So first we will write, because bromo will come first, then E will later. So this is bromo B, this is ethylene E. So first B will come, so dibromo, then bis, ethylene diamine cobalt. Okay, so coming to the third, what is the name for this compound? Nickel A, NH32En, CH3COO2. Can just anyone write in the chat box? What should be the name for compound number? Coordination complex 3. Okay, there is a minor mistake. Again, can anyone point out? That actually I haven't told, but we have already come across those things. That's why I have written this example where the minor mistake is. Two minor mistakes is there in this name, IPAC name. Can anyone just point out here only? So ma'am has written, okay, yeah, one is already corrected, but Diana has done one other mistake. So okay, I think we left that time. Okay, so yeah, correct. So first, this is Me, this is ethylene diamine. So this is 2 is there, so we will write as diamine. Then always we will write whatever this already contain di, those ligand in the small bracket. We have already writing bis diamine, all those things. Ethylene diamine. Then we have to write nickel. What is that oxidation state? This is 2. Then this is ionic. So we have to write cation. Then we have to write anion with space. Acetate. So here there is a space. That is the important thing. Diana, whatever ma'am is there, she has done the mistakes. Okay, coming to the example number 4. But Devendra Malik, I will request like not to give space between the metal and the oxidation state bracket. So you write nickel, then bracket 2, then space between that cationic part and anionic part. Here only one space should be there. So diamine, ethylene diamine, then nickel 2, then space, then acetate. That is the correct answer. Can anyone just try for 4? Coordination number 4. Okay, I think everything is right except one minor mistake is there in this. Can anyone just point out here? Tetraamine sulfato cobalt third nitrite. Can anyone just point out where is the mistake? No, that's fine. Sulfato you can write that way, not in this. But there is one basic mistake. Can anyone just point out? No, still there is a minor mistake. What is anion is? Yeah, now it's correct. So this is nitrate. This is, if it is NO2, this is called nitrate. NO3 is called nitrate. So this is tetraamine sulfato cobalt third nitrate. So here is the mistake. Okay, let me just discuss some of this complexes with anionic coordination sphere. I will just write compound. You have to just tell me the name. Can you people try? The first compound is K2CuCN4. Second is K4NiCN2. C2O4 2. Third is Na2 JDN and fourth is okay. So first halogen potassium tetracyanocuprate 2. Potassium tetracyano. Okay, fine. Just to start with the small potassium space tetracyanocuprate. So this is the what I was thinking that whether like you people are getting or not. So because it is a coordination anionic coordination sphere, so we have to if it is copper we have to add like 80 cuprate other compounds. So I have already written, just you write, then I will one by one I will discuss. So second compound is K4NiCN2 C2O4 2. Can anyone just write in chat box? I think now you people are getting, you haven't written di potassium like that. So this is just to balance the charges and the coordination sphere. Nothing else. Can anyone write for that IPAC name for second? Potassium diacylate. Potassium dioxylato nucleate 0. Can you just check? I think there is minor mistake. Check once again. Potassium dioxylato nucleate 0. So can you just correct where is that minor mistake is? Can anyone point out where that minor mistake is? Ma'am, I have written potassium dioxylato nucleate 0. No, that is correct. Not in this. That is we have to write all those things in the small letter. Nowhere we have to use the capital letter. That is correct. But there is some very basic mistake that you have to point out. Yeah, correctly point out. That is the nickel in the +2 oxidation state. So I will just write now. Potassium dioxylato nucleate. So here So this is cyno C, this is oxalato O. First C will come, then O will come. So dicyno, dioxalato. So this is oxalate. So I already told if it is ATE. Yeah, yeah, correct. See why? Because so this is 2 minus. So 2 I will just write plus 4 plus x minus 2 minus sorry plus 2 multiplied by minus 2 is equal to 0. So now 4 plus x minus 2 minus 4 is equal to 0. 4 cancel out, x is equal to 2. Okay, so that's why you have written a nickel at 0. But here nickel in the plus 2 oxidation state. Yeah. Potassium dicyanovis diacrito. Okay, so wherever Lima mem is already is writing incorrect. So I think so. Whatever rule is that first we have to write in the cation, then we have to write ligand. Ligand we have to write in the alphabetical order. So cyno is C, oxalato is O. So first we will write C cyno, because this doesn't contain di or tri. We will not use the bis, tris, tetrakis, pentakis, all those things. We will simply write di. Oxalate also doesn't contain any ditri, so we have to just write dioxalate. And nucleate, and nickel is not in the plus 4 oxidation state, it is plus 2 oxidation state. I already calculated on the side. So did you get and you have also given like space wrong, like dicyno then space, all those things. I think I have to give one example for that also to where you, so that you can understand. So this is potassium, only space between cation and anion. So your cation may be a simple alkali metal cation, any cation, then coordination sphere with the negative charge, or you have this coordination sphere itself as a cation, and then you have anion like nitrosulfate, chloride, all those things. So we here we this is the like compound with the anionic coordination sphere. So we will write first cation potassium, then dicyno, dioxalato, nucleate plus 2. So even ma'am you got, can you just write in chat box? I think I will give one more example. You will understand where we will use a base, and so you do not have to use any space between writing IPC name. Only space between the uh, no. Oxalate is bidentate ligand. It's fine. But where we will use these trees, where that ligand name itself contain di or tri. So I will just go here somewhere, I think. Okay, here. So suppose we have cobalt En2Br2. So we write dibromo, then ethylene diamine. So ethylene diamine contain already di. So for this we use the bis, trees, all those things. Not for bidentate, tridentate, all those things. We use bis trees if ligand itself contain di, tri, tetra. So for them, if that ligand is having two ligand are joining to the metal center, we will write as bis. 3 we will write tris. 4 we will write tetrakis, like that. Got it? Not like bidentate, tridentate, all these things. Okay, so I have already told all the rules here. What to? Yeah. Can you write the name for third? This is Na2 ZnCl4. Can anyone just write for that third one? Sodium tetrachloro zincate. Yeah, absolutely correct. So we have to write sodium tetrachloro zincate 2. Absolutely correct. So we have to write first cation, then space, then already 4 Cl minus is there, so we will write tetrachloro and then zinc. So for zinc we have to use ATA zincate second. Correct. Yes. So can write for that fourth number. Potassium pentocyanotriol. Okay, there is a minor mistake in potassium pentacyanitrocyle ferrate. Can you guess where is the mistake is? Can anyone just find out where the mistake is? Yeah, absolutely correct. So here you have plus 3 plus x minus 5 plus 0 is equal to 0. So your x is equal to plus 2. So that's already correct. Now potassium pentacyanitrocyle ferrate 2. That is correct. Okay, so I think now this is enough for the naming. So one more rule is there. Once we have both, your cation is also coordination sphere, anion is also coordination sphere. That I have one problem there. I will tell the rule and all those things. Then I will just see whether you people are prepared. So benzoyl acetone has denticity. Can anyone just write in chat box? No, it is not NO plus. It is just simple NO. So I have already told, I think, in the neutral compound, right? Where is that? Yeah. So if you see, this is the nitrosyl. This is a neutral ligand. Can anyone just tell what will be the answer for the question number 1? Benzoyl acetone has denticity. 2436. Can anyone just write in chat box which option is correct for? Anyone else? Okay, ma'am has already told one answer, so I will just do a counter question. Can you just tell me one similar kind of ligand also, which we have come across in the last week or last week lecture, like previous Tuesday? So similar kind of ligand we have come across. Or if anyone has different answer, they can also write in chat box. Yeah, correct. So we have already came across CH3CU, this acetyl AC2 or AC2, whatever it is. So this ligand has two like um, oxygen atom which act as a donor side for this ligand. So this is very interesting. So we have like this. So this is negative. So now it will bind in the meta center Mn plus. So we have something like copper. So we have two like this CuCO2, all those things. For magnesium it is like MnACSE3, like that, whatever it is, all those things. Okay, so this is phenyl. So best here it is just phenyl acetone. Uh, this is benzoyl. So this is benzoyl group, and this is acetone CH3 COCH3. So this is called benzoyl acetone. It has density 2. So two oxygen atom act as a donor. Correct. Next is how many parallel ring present in the porphyrin ring? Can anyone just write in the chat box? What will be the answer for question number 2? How many pyrrole ring present in the pulp? Anyone else who has different answer? Anyone has different answer? Oh, ma'am is saying 3. Anyone else? Okay. So okay. So the correct answer is 4. So 4 pyrrole ring be used to fuse together in a conjugated manner to get the porphyrin ring. So at the end, I will show you that porphyrin ring. Otherwise, let me just show you. So this is your porphyrin ring. So here we have 1, 2, 3, 4. These are the 4 pyrrole ring with a conjugated ethylene linkage. Once we uh, linkage, we will get a heterocyclic ligand that is called porphyrin. Got it? So there are 4 pyrrole ring with ethylene linkage. Once we join, we basically get a heterocyclic ligand which is called porphyrin. Okay, ma'am, is it clear for you? How many uh, uh, pyrrole ring present in the porphyrin ring? Yeah, great. So now question number 3, the ligand system present in the between 12 each. Okay, ma'am is saying coding ring. Anyone else? Anyone has different opinion? Yeah. Okay, so yeah. So between B12, basically we have cobalt 2 with chlorine ring. So that I will show you at the end. Okay, because again I have to go to the end and then show you. So at the end I will show you, and I will tell you people also what is the difference between chlorine ring and porphyrin. How like these are uh, how these two micro uh, like sorry heterocyclic ligand are different at the end of it. So this is again very simple. What is the IPC nomenclature for NaPeCl6 each? Tell me which option is correct. Okay, anyone else? This we have already get enough practice on that. Okay, so I think most of people are already getting correct. So this is the coordination compound with coordination anionic coordination sphere. So for the element we have to use ET. So first we will write sodium, then whatever that ligand, this is chlorine. So chlorine we have 6, so we will write hexachloro. Then this is phosphorus, we have to write as a phosphate, and this is 6 minus 1, so this is 5 is the valency. Correct. The formula for the tris ethylene diamine cobalt third sulfate is, can anyone just write in chat box, because we have already get enough practice for this. I have selected this question because it has some trick. D, anyone else? D, anyone else? So this is in subscription. Sorry, this is not. This is the subscript. Anyone else? Complex tris ethylene diamine cobalt third sulfate. Most of people know. So the correct answer is D. So first thing is that tris ethylene diamine. So first I will write the metal. What is that metal? That is cobalt. Then it is tris ethylene diamine. So ethylene diamine. Tris means already it is die, that's why there is tris. So this is int. Now here is the space, means this whatever anion is there, it is outside, so we have to write as sulfate. Now the thing is that we have to balance the charges. So this cobalt is in the +3 oxidation state, it's already written. So the charge and the coordination sphere will be also +3 because this is neutral ligand. In sulfate it is 2 minus. So now if we want to balance, just balance, suppose this is a x minus b y x plus by minus, so just b, do the reverse. So this 2 will come here and 3 will come here. So very simple. Okay. Next question. The IPSC name for the complex cobalt En2Cl plus. Okay. So what is the correct answer for this? Can anyone just tell what is the answer for question number 6? Okay, anyone else? Okay. I think other people they can also comment on the which is the correct answer for this question number 6. Anyone has different opinion than D? Okay, so the correct answer is D. So how? So first we will write the ligand. So here we have ethylene diamine, that is start with E, chloro start with C, and I try to observe this important thing. This is if it is written NO2, so it is nitro or nitrito N. If it is written ONO, means it's indicating that it is coordinated through O. So we will write as nitrito. So that is the one concept here. That's why we have chosen this one. So this is N. So now first we will first it will come C. So it's already written chloro. Then will come E. So ethylene diamine already has di, so we will write this. So I already told whatever this kind of ligand we have to write in a small bracket. Then this ligand nitrito. Now we have to calculate what is the coordination oxidation state for the cobalt. So this is 1, this is 2, 2 minus, and 1 already plus is there, so this will come. So 2 minus this side, x minus 2 plus 1, so this is x is equal to 3. So it's cobalt 3. So since it is cationic, so we will write just as a D, cobalt 3. Got it? I think other people might have got why the option D is correct. Which are the metal ion present in the coring ring? So this quickly just answer what is the metal ion present in the coring ring. I already told. Magnesium 2 plus, iron 2 plus, iron 3 plus, cobalt 2 plus. Can anyone just tell quickly? Correct. So this coring ring present in B12. So B12 basically it has cobalt 2 plus in the center, and then we have coring ring. Correct. So that's it. As a ligand, Cl minus is. Can anyone just quickly tell me the answer? What is the answer for question 8? Anyone else? We can, if option is also can give a sigma donor, pi donor, sigma and pi donor, sigma donor and pi acceptor. Can anyone just tell me? Anyone else? Okay. Okay, ma'am is saying P donor. Devendra is saying S donor. Okay. Anyone else? No, these like incorrect. Okay. The correct answer is C. It can act as both P donor and S donor. So Cl minus it will bind as S donor, but once it is come to the bridging ligand, then it has like this. Cl minus has how many electrons? Okay. So first minus one it will bind as sigma donor, but once it work as a bridging, so it will donate their pi electron also. Okay, in the bridging ligand. So basically it's like this. Suppose this metal 1, metal 2. So this can donate as a pi donor also, but not it never with a pi acceptor, because it haven't had any vacant orbital where it can accept that electron. So it is both P and S donor. So we can write a sigma and pi donor. Okay. So suppose ligand like CO, it is sigma donor and pi acceptor. So that is a different kind of ligand also, where we discuss that synergic bonding. So that's why metal like nickel present in the zero oxidation state. So this kind of ligand where they are sigma and pi donor, they stabilize the metal in the higher oxidation state. So if you see that whatever chlorine based compound is there, their metal will be always in the higher oxidation state. But go for the carbonyl. So carbonyl is sigma donor and pi acceptor. So this will stabilize the compound in the lower oxidation state metal, like nickel carbonyl, because it will take the electron back from the metal. So it will stabilize the metal in the lower positive oxidation state. Okay, I will go to the next concept. Among RO minus, ES3, Me3, ROR, Cr minus, Cn minus, RCO2 minus, so this is down, is Cn minus, the set of ligand with good pi acceptor. Can anyone just write? So basically pi acceptor will be that one which can accept the pi electron from the metal. Can anyone just write in chat box what will be the answer here? Anyone can guess which will have the good pi accepting property, pi electron accepting property? Can anyone just guess? So I told you one example called CO, carbonate. Now I'm saying B. Anyone else? Anyone else can write in chat box. So I will just give the hint. Pi accepting property ligand which has this pi accepting property, they should have some vacant orbital where that electron from metal can, this back bonding can happen. So which are the ligand which has this empty pi orbital? Can you just see some of them? So I have already used one new term called back bonding. So these are the things I think we have my in the future lecture. What is back bonding? How CO form back bonding and stabilize the metal in the lower positive oxidation state. That is the like, even CO can stabilize metal in the negative oxidation state also. There are examples. So they have that kind of back bonding which can stabilize that metal in the lower oxidation state. Yeah. Now that answer comes, that is C. So B is not. Why? Because C. You have R O minus. So this R already like R will be methyl ethyl. So this all orbital already filled. Oxygen has 2 minus. So that 1 minus is there already. That oxygen, if we see this 2 electron, and already 2 electron from here. So all 8 electron completely filled. So it it can't do back bonding because all the orbital are already filled. But C arsenic has that empty orbital. Then Cn minus, yes, Cn minus, we have to go through the molecular orbital. There you will see that there is a like pi star orbital which is vacant. So that metal can donate their electron in pi star MO of this Cn minus and SCn minus. So our Cn minus SCn minus carbonyl, these are pi backbone are good p acceptor ligand which can stabilize the metal in the lower oxidation state. Okay, so number of donor atom present in the porphyrin ring is, I think this has already come, right? 4. This has already come. And okay, so this is the example which I wanted to discuss. Predict the structure of the complex hexaamine iron third hexacyanochromate third. Can anyone just guess which is the correct answer for this? Uh, can anyone just guess? Predict the structure of complex hexaamine iron third hexacyanochromate third. D. Hexaamine third chromium sign third. Okay, very nice. Everyone has guessed the correct answer. That answer is D. But let me ask in a different way. Suppose I have given this iron NH3 6 and CrCN6. Now you don't know that this is the name. Then how you will find out? Can anyone just tell me verbally or just write in chat box? What is the way to find out that this is the name? This is name already it is given. You just find out and tell that this is option D is correct. But I am asking in the reverse way. Like how you will find out that this is the name for this compound. I just given that name, write the name. What is the concept behind this? Can anyone just write in chat box something? Anyone? Okay, that is not the correct way, but no. X is equal to 2, x is equal to 3. No, no, this is not the correct way. So basically, what I'm telling you that here people should know the variable oxidation state of the metal ion. Okay, so here what is the concept is that you have to know what is the variable oxidation state of metal ion. So iron can exist in +2 +3, chromium can exist in +2 +3 +4, all those oxidation state. So what you have to give, you have to give the plus minus 1 1, other way minus plus then you have to find out all the combination, and you have to see that which suit. Suppose if you put 1, so your iron will be in the plus oxidation plus 1 oxidation state, which is incorrect because iron can't exist in the plus 1 oxidation state, right? So you can see this is the neutral, so this will be the positive. So you give plus 1, here you give minus 1. So here iron you will be your in plus 1 oxidation state, which is incorrect. Then you give plus 2, and here you give minus 2. So what will happen? Your iron will be in the plus 2 oxygen, but chromium will be in plus 4, which may be the correct answer. Then you give plus 3, and here also you give plus 3. Then you will see that iron is plus 3, which is like more favorable, and chromium also exists in the plus 3. So that will be the correct answer. Then you go 4. Iron 4 doesn't exist. Iron 5 doesn't exist. Like no. So this is the best suitable option is plus 3 here also, plus 3 here also. So the first thing is that you have to know the variable oxidation state of metal ion, whatever present is there. So in the periodic table, if you somewhere you find out what is that metal. So in initial you have less variable oxidation, in the middle you have maximum variable oxidation state, at the end you will have the minimum variable oxidation state. Suppose titanium can exist in titanium 3, titanium 4, but in middle like manganese can stable from Mn2 plus to Mn7 plus. But once you give at the end that zinc, it will be found in the either zinc 0 or zinc 2 plus. So like that. So it's like triangle. So at the initial less number of variable oxidation state, at the end less number of variable oxidation state, but at the middle you have the maximum variable oxidation state. So you will find out a triangle kind of thing if you go from scandium to zinc, or for all other also like that. Okay, so here this is the concept, that's why I just kept. So I will just briefly tell you the ligand. So this is the porphyrin ring. So here you have the 4 pyrrole ring. Okay, so 1 2 3 4, and this is ethylene linkage option. Now coming to the B12, so it is chlorine ring. The thing is that here only, here we have this 3 by 4, 3 by 4 only conjugated there. So if I go here, it is fully conjugated. You will see that conjugation starts from here and it will go up to here. But here that conjugation is up to this much only. But here we don't have the concept. So here this is the sp3 hybridized carbon, which give its kind of uh, here it gives the flexibility because it's not planar, but this is completely planar. That ring is completely planar because it's all conjugated, but here this is not conventional. So these two sp3 hybridized carbon give the flexibility to the ring, and this is water solvent. So this is your porphyrin ring present in hemoglobin, myoglobin, cytochrome, nitric oxidase synthesis catalysis. So these are the all biological proteins or enzyme where this porphyrin ring present. Chlorine ring present in the between B12. The thing is that the most important thing is that this sp3 hybrid. This will give the flexibility. Only 3 by 4 is the conjugated, but here it is fully conjugated. Okay, so this is 17 carbon and this is 18 carbon. That is the most important. If you give any net JRF exam, so they will find out, ask you question this which is planar, non-planar, 18 ring, 17 ring. This is one sp3 hybridized carbon is there which give the flexibility. Here there is no sp3 hybrid, it is completed. Okay, so with that I will, I think, stop the this conversation. Okay, so just let me stop the recording now.